The concept of the mole is essential in chemistry for calculating the masses of substances involved in chemical reactions. A mole represents a specific quantity of particles, 6.022 times 10 to the power of 23 atoms, molecules, or ions, and allows chemists to relate the mass of a substance to the number of particles it contains. By using the mole concept, you can determine how much of a substance is needed or produced in a reaction based on its balanced chemical equation. When you have a balanced chemical equation, the coefficients indicate the molar ratio of the reactants and products. These ratios allow you to calculate the masses involved in the reaction. For instance, consider the reaction between hydrogen and oxygen to form water. Please pause to take note of the formula on the screen. This equation tells you that 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of water. If you know the mass of one of the reactants, you can calculate the mass of the products. For example, if you have 4 grams of hydrogen, which corresponds to 2 moles, since the molar mass of hydrogen is 2 grams per mole, you can calculate that it will produce 36 grams of water, since each mole of water has a mass of 18 grams. You can also use moles to balance chemical equations by working with reacting masses. If you know the masses of the reactants and products, you can determine the number of moles involved and adjust the coefficients in the equation accordingly. For instance, if you start with 12 grams of carbon and 32 grams of oxygen and want to form carbon dioxide, you calculate the moles involved, 1 mole of carbon and 1 mole of oxygen, leading you to write the balanced equation. Please pause and take a note of the formula on the screen. In this reaction, 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide, matching the masses you began with. By using moles to calculate masses and balance equations, chemists can precisely measure and predict the outcomes of chemical reactions, ensuring that the quantities of reactants and products align with the principles of conservation of mass. This approach is fundamental to both theoretical and practical chemistry, allowing for accurate planning and analysis in various chemical processes.